Hi guys, how are you? I guess now problem has given you the idea that what are you into and how to prepare for the interviews, right? So anyway, as a promise, I am coming with some of the answers. Okay, so let's go directly to the questions and answers. So now draw pH and TS diagram. I might have done some live video how to draw. Maybe we can have the separate session for pH diagram drawing, but it is simple if you go through the book. It is a pressure line. Okay, see, this is this is pressure, this enthalpy axis, then this is what is uh, this is saturated liquid, this is critical point, this is saturated vapor region, then this is constant pressure line, this is subcooled liquid region, and this is wet region. So this is overall the basics of the diagram, but what is actually needed is this is what pH diagram means. This is what you have to draw. Like this is simple condensation, and this is expansion, this is again evaporation, and this is compression. So it should be like somewhat rectangular, but not total. This compression line should be slant over here, this superheat and this desuperheating. So from this saturation vapor line there should be some gap. So this is representing the superheat, this is representing desuperheating. Again you have to think of the constant volume lines. This is mentioned constant entropy lines, then constant temperature lines. It depends on how your interviewer is. Generally what happens when you draw something and you trying to explain, they catch some of the things, then they may ask what is the specific volume, what is the constant volume, this is some term, what is a critical point, they may ask. So these are the questions they can ask. So when you are going to draw the diagram, you should be thorough through the diagram. At least you should know at least 80% of the diagram. Okay, let's go to the next slide. It is a TS diagram. I have kept very simple over here. Again it is a temperature, and over it is a enthalpy, and this is critical point, and this is somewhat the curve is different. In pH diagram it is like this, and in TS it is this. So you can see here there is a horn, this is called horn, and this is desuperheating zone, this is condensation, this is expansion, this is evaporation, this is high pressure lines, low pressure line. Again here you can draw high temperature line, low temperature line. So you can go through. This is critical point, it is there. So people may ask what is the critical point, they may ask what is the entropy, how it is linked with the temperature and all that. So you have to prepare for pH diagram and TS diagram thoroughly. Now going across to the next question, that is a question number 7, what is enthalpy. It is very important term because the thermodynamic itself start with the enthalpy. So in word of thermodynamics, enthalpy H means the sum of internal energy. So I need not to explain what is internal energy right now, considering that at least you are the graduate guys, or even in diploma it is taught. So then it is a product of, plus it is a product of pressure and volume. So hence enthalpy is equal to H is equal to U plus P. You can see here, you can see H is capital, U is capital, P and V is small. So it is for the this. So going for the unit mass, it is the H will be small, U will be small, P is small here also as it is, and V will be small because here we are going to use the specific volume, because for unit volume it will be specific volume. Okay, let's go to the next. What is entropy? The question asked was what is entropy. I told actually these are the terms or the interview will ask during, even when you are drawing pH diagram or TS diagram. So let's entropy means the transformation. This thermodynamic property increases with the addition of heat and decreases with the removal of heat. Okay, so actually literally entropy means a transformation, but it is very difficult to tell single term as an entropy. So it is better actually scientists have defined that the change in entropy, it is very easy to define change in entropy rather than the single term entropy. So therefore people generally thinks what is the change in entropy. So actually the if we are going to define what is the change in entropy in mathematical model, it is, if you directly go like del q to t ds is equal to, so you will come to the this particular part, ds is equal to del q by t. Okay, so this is a change in entropy. Now some people have different terminologies for the different symbols, so don't worry about that. You can say the infinitesimal change in q is equal to t into ds. Okay, let's go to the next question. So what is subcooling? So it is when refrigerant, see, you can see here, again it is a pH diagram. This is actually P and this H. This is a critical point. Okay, so subcooling. So this is, you can see this is condensation. This is condensation. So subcooling is mainly focused in the condensation area. The condensation. Okay. So after condensation, what will happen? Uh, because of the ambient cooling, the refrigerant at a high temperature and high pressure will cool down to the liquid. Okay. So when refrigerant after condensation process is cooled below the saturation temperature and before expansion, this is the expansion process, is called the subcooling. So this region particularly, this, let me write, this particular this particular region is called subcooling. So generally in many of condenser coil they keep the extra space for the subcooling. So before expansion they will subcool. Why subcooling? So this is called, again I am summarizing what is subcooling. When refrigerant after the condensation process is cooled below the saturation temperature before expansion by throttling is called a subcooling. Okay, let's go to next. So why subcooling is beneficial? So subcooling is beneficial, if we go, why subcooling is beneficial? Because if you see, it is going beyond the saturation line. Okay, liquid saturation line. So if you draw the perpendicular to it, it will increase your net refrigerant effect, and hence net refrigerant effect. So CO, what is COP? COP is equal to net refrigerant effect upon, theoretically, upon compressor work done. Okay, so your COP will increase because your net refrigerant effect is increasing. Your compressor work is same, but by subcooling your net refrigerant is effect is increasing. Hence the COP is increasing. So subcooling is beneficial because the cooling of refrigerant below the saturation temperature increases the net refrigerant effect and hence more COP. So what is superheating? Now again, superheating is this particular area. I have already shown in red over here. Okay, this particular is called superheating. It is evaporation. After evaporation of the vapors through the evaporator, it goes to suction line. This is the suction line. This is the compressor. So actually, in industry, superheating is, there are two uh, basic requirements. First is there should not be any liquid particle or liquid phase of the refrigerant which is going into the compressor, because it may damage the walls of the compressor. Okay, another is it can, because of superheater, moistures will not, again the part of moisture which is not a part of actually the refrigerant, but it superheat ensures that it will not go to compressor. Okay, so there is a degree of superheater term. If you want, you can go through the terms of the book and you may understand. So this is, again we are talking about what is the interior, what is superheating. You have to just explain this area is a superheating. The refrigerant after evaporator is made heated in suction line. This is the suction line to form pure vapors, to ensure liquid vapors in compressor called superheating. Okay.